Welcome everyone to this course on Secure Development Methodologies. My name is Your Name, and I'll be your instructor as we navigate through the essentials of developing secure software applications. I'm excited to have you all here, and I look forward to sharing my knowledge and experience in this crucial area of software development. Objective. Our primary objective in this course is to learn and apply secure development methodologies to enhance the security of your software applications. By the end of this course, you will have a comprehensive understanding of key security practices, and you will be equipped with the tools and techniques needed to integrate security into your development processes effectively. In today's digital world, the importance of security in software development cannot be overstated. Cyber threats are becoming increasingly sophisticated, and the potential damage from security breaches can be devastating. This course is designed to help you stay ahead of these threats by incorporating secure development practices right from the start of your software development lifecycle. Here's a brief overview of what we'll cover. The fundamentals of secure development. We'll start by understanding the basic principles and importance of secure development. Threat modeling. You'll learn how to identify, analyze, and mitigate potential security threats. Secure coding practices. We'll delve into best practices for secure coding, focusing on common vulnerabilities and how to avoid them. Security testing. We'll explore various techniques and tools for testing your software for security issues. Integration of security in DevOps. We'll discuss how to incorporate security into continuous integration and continuous deployment (CD) pipelines. Compliance and standards. We'll review industry standards and regulatory requirements to ensure your software meets legal and compliance obligations. This course is designed to be highly interactive, with a mix of lectures, hands-on exercises, and real-world examples. You'll have plenty of opportunities to engage with the material, ask questions, and participate in discussions. Getting started. To get the most out of this course, I encourage you to actively participate, complete the exercises, and take advantage of any additional resources provided. Don't hesitate to ask questions or seek clarification on any topics that may be unclear. Let's embark on this journey to becoming more proficient in secure development methodologies together. Your commitment to enhancing the security of your software applications will not only protect your organization, but also contribute to a safer digital environment for all users. Thank you for joining this course, and let's get started. Welcome to the next segment of our course on secure development. Let's delve into the core fundamentals by addressing the question, what is secure development? First, let's draw upon a powerful quote from Bruce Schneier. Security is not a product, but a process. This encapsulates the essence of what we aim to achieve through secure development. It's not about setting and forgetting. It's about constant vigilance and integration of security at every stage of the software development lifecycle, or SDLC. So what exactly do we mean by secure development? Secure development involves embedding security practices throughout the SDLC, from initial design to final deployment and maintenance. This proactive approach is aimed at mitigating vulnerabilities and protecting against an ever-evolving landscape of threats. To break this down further, let's explore 3 key points. 1. Integration of security practices. Introducing security measures as early as possible in the development process ensures that you're building on a robust foundation. Security isn't an afterthought, it's a part of each phase, from requirement gathering and design to coding, testing, and maintenance. 2. Importance of secure development. By integrating security early and consistently, we ensure that the applications we develop are robust and trustworthy. This reduces the risk of security breaches, which can have devastating effects, such as data loss, financial damage, and reputational harm. Moreover, secure development enhances compliance with security standards and regulations, which is crucial for avoiding legal repercussions and fostering user trust. 3. Constant vigilance. Security threats evolve, and so must our defenses. Continuous integration of security practices ensures that we remain vigilant and our applications remain secure against emerging threats. So now, let's consider this critical question. Why is integrating security early in the SDLC crucial? There are several compelling reasons. Cost-effective. Identifying and addressing security issues early in the development process is generally more cost-effective than fixing them after the product has been deployed. Prevents serious breaches. Early integration of security can prevent significant vulnerabilities that could be exploited by malicious actors, thereby averting potential data breaches or attacks. Increases trust and compliance. Building security into your processes ensures that the final product meets industry standards and regulatory requirements, which is crucial for maintaining user trust and avoiding penalties. In summary, secure development is not just a step in the process. It is interwoven through every phase, ensuring that your applications are safe from the ground up. By doing so, we can create applications that are not only functional, but also secure and reliable. In the subsequent slides, we will delve deeper into specific practices and methodologies that can help us achieve secure development throughout the SDLC. Ready to jump into the specifics? Let's move forward and explore how we can practically apply these concepts. All right, welcome back, everyone. In this module, we are going to dive into a critical aspect of software development: security. More specifically, we'll be talking about the Microsoft Security Development Lifecycle, or SDL. Slide 3 appears Microsoft Security Development Lifecycle. So what exactly is the Microsoft Security Development Lifecycle, or SDL? Let's break it down. Overview of Microsoft SDL. The SDL is a process introduced by Microsoft designed to integrate security into every phase of the software development lifecycle, SDLC. This integration helps ensure that security considerations are not an afterthought but a fundamental part of the development process. Implementing security at each stage helps in proactively identifying and mitigating potential security issues. Key principles. 1. Training. Regular security training for developers. The cornerstone of SDL is ensuring that the entire development team is well-versed in security best practices. This means regular, mandatory training sessions that keep everyone updated on the latest security threats, coding techniques to mitigate those threats, and company-specific security policies. Training helps the developers build a security-first mindset, which is crucial for developing secure applications. 2. Requirements. Define security requirements from the start. At the beginning of the project, it's vital to define security requirements, just as you would for functional requirements. This means identifying what kind of data needs protection, regulatory requirements that need to be adhered to, and potential attack vectors that need to be mitigated. By establishing these requirements early on, you set a solid foundation for a secure development process. Design. Perform threat modeling and establish design requirements. Before a single line of code is written, you should be thinking about security. Perform threat modeling to identify potential security threats and vulnerabilities. Establish design requirements that address these threats and incorporate security features into your design. This stage is crucial because fixing security issues at this phase is significantly less costly and time-consuming than addressing them later. Now, you might wonder if these principles make a tangible difference. Example: a company using SDL successfully reduced vulnerabilities by 50%. To illustrate the effectiveness of the SDL, consider this real-world example. A company that rigorously implemented the SDL framework was able to reduce its software vulnerabilities by 50%. This dramatic reduction highlights how integrating security into each phase of the development lifecycle can not only improve software quality, but also enhance overall business resilience. By adhering to these key principles, training, defining security requirements early, and rigorous design, Microsoft's SDL framework helps create more secure, robust software while reducing the risk of vulnerabilities. So as you develop your own projects, think about how you can integrate these SDL principles into your workflow to ensure that security is not just an afterthought, but a core component of your development process. All right, that's a wrap for this slide. Let's move on to how we can practically implement these principles in our next segment. Welcome back, everyone. In this module, we're diving into the detailed phases of the Microsoft Security Development Lifecycle, or SDL. On slide 4 here, we break down each phase and its specific focus areas. Let's go through each phase step by step to better understand what they involve. 1. Training. The first phase is all about security education and awareness. Here, teams undergo training to understand security principles and best practices. This phase ensures everyone involved is on the same page regarding security requirements and threats they may encounter. 2. Requirements. Next, we have the requirements phase. In this phase, we define security and privacy requirements for the project. This lays the foundation for all subsequent security activities. It involves identifying regulatory compliance, business needs, and risk assessments. 3. Design. Moving on to the design phase, teams perform threat modeling and attack surface analysis. Threat modeling helps identify potential threats, and attack surface analysis helps to minimize the vectors that an attacker could exploit. 4. Implementation. The implementation phase is where the rubber meets the road. Development teams adopt secure coding standards and perform static analysis. Following secure coding practices ensures that vulnerabilities are minimized from the outset. 5. Verification. In the verification phase, teams conduct dynamic analysis and fuzz testing. Dynamic analysis involves running the application to find security vulnerabilities, while fuzz testing involves inputting unexpected or random data to ensure the software can handle anomalous conditions gracefully. 6. Release. The release phase includes incident response planning and final security review. Before software hits the market, it's vital to conduct a thorough security review and establish a plan in case things go wrong post-release. 7. Response. Finally, there's the response phase. This involves post-release monitoring and response. Even after thorough testing, some vulnerabilities can still surface. This phase ensures that there's a plan to respond to new threats and vulnerabilities quickly and efficiently. While each phase is critical to the overall success of a secure software development lifecycle, I'd like to hear from you. Which SDL phase do you find most challenging? Think about your experiences and where you often encounter roadblocks. Maybe it's the comprehensive nature of threat modeling, or perhaps maintaining secure coding standards during implementation. This question is crucial because understanding our challenges helps to focus our efforts and improve our processes. Feel free to share your thoughts in the chat or use the Q&A feature to discuss your experiences. Let's learn from each other's challenges and successes. Welcome back, everyone. In this segment, we're going to explore an essential concept in the realm of software development and security, Cigital security touchpoints. This framework, developed by Gary McGraw, is all about embedding security measures seamlessly throughout the software development lifecycle, SDLC. Overview. Gary McGraw, a pioneer in software security, designed the Cigital security touchpoints to enhance and ensure robust security in software systems right from the development phase. The primary goal is to integrate security practices at every stage, minimizing vulnerabilities and ensuring that the final product is not only functional but also secure. Key concepts. Let's break down the key concepts within this framework. 1. Code review. Purpose. Code review is crucial for identifying security flaws at an early stage. It's a systematic examination of the source code aimed at uncovering security vulnerabilities that could be exploited. Process. This involves both automated tools and manual inspection. Automated tools can highlight potential issues, but a human review is often necessary to understand the context and mitigate false positives. 2. Architectural risk analysis. Purpose. This step focuses on evaluating the design of the system to identify and assess potential security risks. It's about understanding the inherent risks associated with the system's architecture. Process. This involves reviewing architectural diagrams, data flow diagrams, and other design documents to pinpoint where potential security issues might arise. Addressing these risks early can save significant costs and effort later on. 3. Penetration testing. Purpose. Penetration testing, often referred to as pen testing, is a method where simulated attacks are performed on the software to uncover vulnerabilities. It helps in understanding how the system holds up against real-world attack vectors. Process. This is usually conducted by ethical hackers or specialized security teams who mimic the attack strategies of malicious actors. The insights gained from these tests are invaluable in strengthening the software's defenses. Quote, to encapsulate the essence of these touchpoints, Let's reflect on a quote from Gary McGraw: "A little security goes a long way." This highlights the importance of integrating even small, seemingly incremental security measures at various stages of development, which can result in significant improvements in the overall security posture of your application. In conclusion, by embracing Cigital security touchpoints, we can systematically and proactively address security concerns, thereby creating software that is not only functional, but resilient against potential security threats. So, let's integrate these practices and build secure software from the ground up. Thanks for joining, and let's continue with how we can apply these principles in our projects. Certainly, let's dive into the topic of applying Cigital security touchpoints in practice. Slide 6, Cigital security touchpoints in practice. When we talk about security touchpoints, we're referring to key practices that help ensure the security of our software throughout the development lifecycle. Today, we're focusing on 3 critical touchpoints: code review, penetration testing, and risk analysis. Let's explore each of these in more detail. 1. Code review. Code review is the process of systematically examining the source code with the intention of identifying and fixing security vulnerabilities. Automated tools. These tools scan the codebase to detect known security issues and ensure compliance with coding standards. Examples include static analysis tools like SonarQube or checkmarks. Manual inspections. This involves experienced developers or security experts manually reviewing the code to spot subtle issues that automated tools might miss, such as logic errors or context-specific vulnerabilities. The goal here is to catch and fix security flaws early in the development process, ideally before the code goes into production. 2. Penetration testing. Penetration testing, often referred to as pen testing, is a proactive approach where security professionals simulate attacks on an application to uncover vulnerabilities. Scheduled tests. These tests are often conducted at specific intervals, such as before a major release or after significant code changes. Integrating feedback. After a pen test, it's crucial to take the findings seriously and integrate the feedback into your development process. This might involve fixing the issues identified and updating security practices to prevent future vulnerabilities. Penetration testing helps to validate the effectiveness of your security measures and identify potential exploits in your application environment. 3. Risk analysis. Risk analysis involves continuously assessing and updating threat models to reflect the current security landscape and identify potential risks to your application. Regular updates. Threat models should be revisited regularly, especially as new threats emerge or when significant changes are made to the application or its environment. This practice helps to ensure that you are aware of and prepared for the latest threats, guiding your security efforts towards the most significant risks. Question: how does code review differ from penetration testing? Great question. While both code review and penetration testing are essential for securing software, they differ in their approach and focus. Code review focuses on examining the application's source code, typically conducted during development before the code is deployed, can be both automated using tools and manual, aims to find and fix security flaws in the codebase itself. Penetration testing focuses on the application in its deployed state, simulating real-world attacks. Conducted by security experts who attempt to exploit vulnerabilities from an attacker's perspective, scheduled periodically or in response to significant changes, aims to uncover vulnerabilities that could be exploited in a live environment. In summary, code reviews aim to prevent security issues by scrutinizing the source code, while penetration tests seek to identify vulnerabilities in the deployed application that could be exploited by attackers. By combining these approaches with regular risk analysis, you create a robust security framework that addresses potential threats from multiple angles. That wraps up slide 6. I hope this gives you a clear understanding of how to apply Cigital security touchpoints in practice and the distinct roles each touchpoint plays in securing your software. If you have any questions, please feel free to ask. Modern CI/CD with integrated security. Welcome everyone to this section on Modern CD with integrated security. Our focus here is on how to build secure CI/CD pipelines that not only ensure rapid delivery, but also maintain the integrity and security of your code throughout the development lifecycle. Continuous integration and continuous deployment, CI/CD with integrated security checks. Let's start with the basics. Continuous integration, TRAR, and continuous deployment, CD, are practices aimed at merging code changes frequently and deploying them to production rapidly. However, modern CI/CD pipelines need to address not just functionality and performance, but also security at every stage. That's where integrated security checks come into play. Here are benefits of secure CI/CD pipelines. 1. Automation. Automation helps by reducing human errors and considerably speeding up the detection process. Imagine catching vulnerabilities and misconfigurations early in the development cycle, rather than at the end, or worse, in production. This not only makes your pipeline more efficient, but also your overall project more secure. 2. Scalability. As your project grows, so do your security concerns. Integrated security solutions can scale seamlessly. This means your security processes can grow proportionally with your project without becoming a bottleneck. 3. Real-time feed. A significant benefit integrating security into your CI/CD pipeline is the availability of real-time feedback. This means any security issue can be identified and resolved immediately before it escalates or spreads. This also fosters a culture of continuous improvement and proactive maintenance in your development team. Let's underscore this with a powerful quote from Bill Gates. Automation applied to an efficient operation will magnify the efficiency. This holds especially true in the context of secure CI/CD pipelines. When you integrate security checks as part of your automated pipeline, not only do you elevate the operational efficiency, but you also ensure a strong defense mechanism is consistently enforced without additional overhead. In summary, integrating security into your CI/CD pipeline isn't just a good practice, it's becoming an industry standard. Automation enhances efficiency, scalability ensures that your security measures grow with your project, and real-time feedback allows for immediate resolution of issues. This integrated approach results in more secure, reliable, and robust applications. Thank you for your attention. Let's move on to the next slide where we will talk about specific tools and strategies for implementing these secure CI/CD pipelines. Welcome back, everyone. In this module, we're going to delve into the best practices for implementing security in your CI/CD pipeline. As we move towards more automated and integrated development processes, it's critical to ensure that security is not an afterthought, but rather an integral part of our workflows. Let's walk through some key practices that will help you build a robust, secure CI/CD pipeline. First up, we have static analysis security testing. This method involves analyzing your source code or compiled code for vulnerabilities. One of the significant advantages of SAST is that it is performed during development, which means you can catch vulnerabilities early before they make it into the production environment. Think of it as a proactive measure, identifying and rectifying issues while the code is being written. Next, dynamic analysis security testing, DAST, comes into play. Unlike SAST, which tests the code, DAST focuses on testing the running application. This method is critical for identifying security issues that only manifest when the application is operational. It provides an additional layer of security by simulating attacks on the application from an external perspective. We also have dependency scanning. Modern applications often rely on numerous third-party libraries and dependencies. While these can significantly speed up development, they also introduce risks if not properly vetted. Dependency scanning helps in identifying known vulnerabilities in the third-party libraries you're using. Up-to-date scanning ensures that any security holes and dependencies are caught before they can be exploited. Another crucial practice is secret management. Sensitive information such as API keys, passwords, and certificates should never be hard-coded or stored in plain text. Robust secret management tools and processes help in encrypting, storing, and handling sensitive data securely. This ensures that even if your codebase is compromised, your secrets remain protected. Now I'd like to pose a question to you all. Which security testing method is best suited for early detection of vulnerabilities? By now, it should be clear that static analysis security testing, SAS, is the most suitable method for early detection. Because it is performed during the development phase, SAST allows you to identify and fix vulnerabilities before they become deeply embedded in your codebase. In summary, integrating these security practices, SAST, DAST, dependency scanning, and secret management into your CI/CD pipeline can significantly enhance the security posture of your applications. Automating these processes ensures continuous security, keeping your applications safe from emerging threats. Thank you for your attention. Let's move on to the next slide to discuss how we can implement SAST effectively. Shall we? Slide 9. Welcome back, everyone. Now let's dive into a crucial aspect of maintaining robust security in our projects: continuous improvement and monitoring. Importance of continuous improvement. In the world of cybersecurity, the landscape is ever evolving. New threats emerge daily, and our countermeasures must evolve just as quickly. It's not enough to set up security protocols once and believe the job is done. Continuous improvement ensures that our defenses remain strong and relevant. Ongoing monitoring. Regular updates and monitoring of security measures are key to this process. When we talk about ongoing monitoring, what we mean is having a dedicated practice of continuously checking that all security systems are functioning as expected. This includes, but is not limited to, patch management, vulnerability scanning, and anomaly detection. By regularly updating our security measures, we are better equipped to defend against the latest threats. Feedback loops. Another critical element is incorporating feedback from security incidents and audits. Serious learning opportunities. When an incident occurs, it's essential to ask, what went wrong, and how can we prevent this from happening again? Similarly, audits provide valuable insights into potential vulnerabilities. Keeping these feedback loops active ensures we don't repeat the same mistakes. Training. Continual education of development teams on new security practices and emerging threats is also imperative. Security is a rapidly changing field, and ongoing training helps maintain high levels of awareness and proficiency among team members. This includes up-to-date knowledge on the latest security tools, techniques, and compliance requirements. Quote. To emphasize this point, let's reflect on a quote by Mark Benioff. The only constant in technology is change. This couldn't be more true in the context of cybersecurity. Embracing change and making continuous improvement a part of your culture is vital for staying ahead of threats. Activity. Now let's put this into practice. I'd like you to take a few minutes and develop a plan for continuous security improvement for your current project. Consider what specific actions you can take under ongoing monitoring, feedback loops, and training to ensure your security measures are always up to date. If you have any questions or need help getting started, feel free to ask. Let's make sure we're always improving and staying secure. And there you have it, an in-depth look into the importance of continuous improvement and monitoring in cybersecurity. Thank you for your attention, and let's move on to the activity. Slide 10, Conclusion and Next Steps. All right, we've reached the final slide of our course, and it's time to wrap things up and talk about how you can move forward from here. There's a lot we've covered, so let's ensure you have a clear understanding of the key takeaways and next steps. Wrapping up and moving forward. Recap. Importance of secure development. We started with the fundamental importance of secure development. Security should never be an afterthought. It's a crucial part of the software development lifecycle right from the initial stages. Key methodologies. Microsoft SDL, Security Development Lifecycle. We explored Microsoft SDL, a process that embeds security into every phase of the development process. Remember, incorporating security at each step helps in early detection and mitigation of vulnerabilities. Cigital Security Touchpoints. We dipped into Cigital's security touchpoints, focusing on identifying and addressing security risks through code reviews, architectural risk analysis, and penetration testing. CI/CD with security. We examined how to integrate security seamlessly into CI/CD pipelines, ensuring that every build and deployment is secure without slowing down development. Next steps. Now that you have a solid understanding of these concepts, let's discuss how you can apply them and continue honing your skills. 1. Apply these methodologies in your projects. Start integrating the best practices from Microsoft SDL, Cigital security touchpoints, and secure CI/CD methods into your own projects. Treat security as a continuous process, not as a one-time task. 2. Continue learning and stay updated. The field of cybersecurity is always evolving. Make it a habit to stay updated with the latest security trends, tools, and best practices. Pluralsight, for instance, has a wealth of resources to keep you informed and skilled. 3. Join security communities and forums. Engaging with communities is a great way to stay informed and exchange knowledge. Participate in forums like Stack Overflow, Reddit's cybersecurity communities, or professional groups on LinkedIn. This not only helps you learn, but also provides a platform to seek advice and share experiences. Ultimately, the pursuit of secure development is a continuous journey. By applying what you've learned, keeping yourself educated, and engaging with the community, you'll significantly contribute to building more secure applications. Thank you for being a part of this course, and I wish you the best as you implement these security practices in your development workflow. Stay secure and happy coding.